Muhammad lana wali walidina warhamhuma kama rabbayana sigara rabbi sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli rabbi zidni ilma warzuqni fahma rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar amin ya rabbal alamin. Bro, can you see my background?
Yes, I can see.
It's cool, eh?
Yes, I can see.
All right, today will be our special edition, a gift from us, from me, Dr. Mark, and Dr. Farah. And student will ask why we have a special edition today. Yeah, why? Because we three of us feel your stress, guys. And stress reveal who you are. Either you are independent, creative, innovative thinker, or just a lazy, crazy scoundrel. It is quoted from my presentation when I was in Groningen, Professor Olaf Scotland. Bro, is it all right?
Okay.
Not yet?
Yes, it's okay. Okay, now. There's some interference.
Yeah.
Yes. Okay.
But you can see, you can look at my presentation,
Yes.
right?
Yes, we can.
Okay. So we don't want you to become the latter, you know, the crazy, lazy scoundrel. Even though you have potential to become one. Therefore, special edition, here we go. So I would like to invite Dr. Farah and Dr. Mark to the podium. We don't have podium, but you know what I'm saying. We want to explain to student Dr. Mark and Dr. Farah what is the difference between module and practicum. You know, in practicum, we also have some guideline, right? We call it also module, but it is not module actually. In practicum, you do what you are taught. All right, Dr. Mark? We got some guideline and we have to measure this, we have to measure that. In module, you do whatever you need to do to achieve the goal. So you only provide some information, short, brief information that you have to get this value. It doesn't matter how you will get it, but as long as you can get it. So that's the first difference between module and practicum. Practicum, yeah, this one, evaluation is based on your performance, how good you are when measure some quantity in the experiment, how good you are using a caliper, for example. Or yes, Mark?
No, it's not me.
Okay, sorry. I thought it was you. How good you are when doing some measurement. That's practical. In module, it is okay if you cannot use computer. It is okay if you cannot have a very good understanding of mathematics. The evaluation is based on your argument. You see the difference, right? Practicum, limited time, no time to explore. You have to do it in certain amount of time. You have to finish this procedure. That's practicum. And then finally, you have a report. In module, also limited of time, also require you to write a report, but if you don't explore, you cannot achieve the goal. How? But it is limited of time. Well, yeah, that's true. But nobody asks you to do only one way. You are free to do whatever you want. So the conclusion is, practicum is for sissy, module is for macho, you know, and we want you to be a macho. We want you to be macho, not sissy. You should see, you know, I do whatever. I have been told this, I do this. And when somebody asks me, why you do this? I have been told to use this. I have been told to do this. So I cannot take any responsibility. That's not what we want you. We want you to be responsibility with your whatever you choose to do. So Dr. Mark, what do you think? Maybe you have some suggestion or some comment.
I think it'd be good that if we go through maybe some of the important aspects of each module, and as well, we can open the floor to our students for them to ask questions and we answer them one by one. What do you think?
Okay, and perhaps Dr. Farah, I want to say something before we go because it is not the long, Dr. Farah?
Yeah, I think my student learn a lot from module and they just realize the difference between module and
Yeah, please understand the difference. We can go back to this concept, but this presentation only few pages, so don't worry. It is a special edition. All right, I will go for the next slide. Common mistake. Yeah, common mistake. This is a rookie mistake, We must get the answer right. This is our mentality, And if we get a bad grade if we make a mistake. So I don't want to make a mistake because I don't want to get a bad grade. So this is also our common conception. And these two can be simplified by this conclusion. Do not go there. Curiosity kills the cat. So this is our mentality. Well, at least you guys, your mentality, guys, not Dr. Mark, not Dr. Farah. Me, I also do this. I also afraid. But Dr. Farah and Dr. Mark, they were never afraid of anything, So you guys need to change the mindset. What is the correct mindset? So you know that this three is not correct. No, it is not correct. This is the correct one. Science is about making a lot of mistakes. And curiosity kills stupidity. You must be curious. Otherwise, you keep your stupidity in your head. When somebody asks you why you do this, I don't know because I got used to it. That's not the correct answer. Habit is not the correct answer. And that's why we provide you a module to increase your curiosity, to give you opportunity to explore many things. It is all right if you cannot get the correct answer. It is all right, as long as you have the argument. Finally, the last slide, we encourage you to explore many mistakes in the module. You do some exploration. You have Gauss view, right? Use Gauss view 6 is the best software in the whole universe, in the world, yeah, in the whole universe right now for chemistry software, for the visualization of the chemistry result. You cannot get better than that. So if you have Gauss view in your hand right now, and you don't explore it, or at least you use it for your bachelor thesis, PT, guys. That's the most expensive software right now, and it is in your hand. Well, of course, you hijack it, but nobody knows that. Don't worry. We encourage you to explore, make mistakes. Must be plural. Make mistakes, and importantly, more than exploration, more than making mistake. What is the thing that most important than these two? Is make a lot of friends. This is the most important one. That's why we make a group between you two. I always told to my student, look, Malaysian student is so macho, They are not CC. So you gotta make a friend with them.
Oh.
So that's why you have to collaborate. Make a lot of friends. And finally, after the following comment, I would like to ask comment from Dr. Mark and Dr. Farah. We are going to explore NBO results. And since you now guys know that you have to be determined, explore, and you love cats, so you are going to accept the challenge to listen to our demonstration of how to use NBO. All right, Dr. Mark, thank you for your time. Special edition. Special is always short, you know. You cannot have special with a long duration of time. Please give your thought.
Are we going to resonance topic today?
No. It is
No, right?
special topic, it is special edition, Dr. Mark.
Okay, but
Don't let them stress again.
yeah, it's
Just demonstration
exploring
because they need NBO for the resonance and the next.
resonance.
Yeah. So Dr. Farah will make some demonstration.
Okay. So what shall we do right now? I mean, should we?
No, I mean we need to explain to students that our task, the module, not to make them stress.
I think I've said this many times.
But they don't believe you.
Somehow I think also they are also stressed out because of their final year project.
Yeah, I know.
So
True.
So that's why I also extended the submission of our module.
True.
So I'm also listening to the complaints of my students.
Yeah.
I'm trying to help them as much as I can. So I think they're also very proactive right now. They have asked questions on YouTube channel, which I put up for our previous class.
Yeah, I heard that.
Yeah, if there's any questions, actually, you can also ask so that we can talk. I mean, we can discuss about it. I think that's all for me.
Yeah.
Yeah.
Dr. Farah, before we ask student, perhaps they have some question about the module, not about the material, okay? About the module. About the philosophy of our class.
Sorry. Can you hear me?
Yes, we can hear you, but you are freezing.
Yes.
Oh, yeah. About the last module.
Yeah,
Are you freezing?
Some bad connection of that.
Disconnected.
Yeah. I'm sorry. I just joined.
Oh, all right.
Sorry, I cannot hear you.
Yes, we can hear you. We can hear you.
Okay. So about the previous module, I think they do a lot of things and they're stressed a lot. So we cannot wait for this special edition. And they are so curious about this special edition because they think that they will learn about resonance.
Yeah, resonance is a special topic, but not special edition. Special edition, the spirit of special edition, to give our students some time to breathe, right, Dr. Mark?
Yeah, to reflect on what they have done.
Yeah.
True. So guys, if I may allow go back to my presentation, actually I intended to make this presentation, Mark, because I have special feature now. Can you do this? You know, my background is my presentation, you see?
Is this from Zoom?
Yeah, Zoom.
I think because you're rich, you purchased this license. I need to get a license from you.
Guys, this is the most important thing. So if you just know about what is the difference between module and practicum, at least next time, if you want to go to a master degree, or even if you want to go to work, you know, industry, you know that science is about exploration and it is okay to make mistakes. But if in industry, you don't have to be curious. So that's the difference between science and non-science. True, science needs money. We need fund. And in the end, if we get the result, well, you know, technology born and so on. So this slide is the most basic of philosophy between modules and practicum, and you need this to understand so you can change your perspective, especially my students in Unair, Airlangga, since most of you are in the 3rd year, so you still have 1 year to come to change this mentality. Do not be shishi, be macho. Macho what does it mean? You take your own responsibility for whatever you decide. So you cannot say why you take this road, why you go that way, because I have been told to go that way. So I don't want to take responsibility for my actions. Wrong. No, I take this way because that's my plan. If I make it wrong, I will take responsibility. That's macho. What do you think, Dr. Mark?
Yeah, they are very much motivated right now.
If you ask Dr. Mark, he never make a mistake, rookie mistake. So that's why he becomes a lecturer. And after he got a lecturer, now he realized he make a mistake. Oh, I should go to industry. I should be rich now. So it is better for you to make a mistake right now before you decide what are you going to do after your graduation. Do not be like Dr. Mark. He is sorry when he becomes a lecturer. All right, students, if you have any question, my student as well, if you want to have some question, please raise your hand. And perhaps admin, please help us if the microphone was not available.
I think there's the questions from the chat
Please.
box. Who is this?
Let me open.
Question directed to you. Excuse me, Dr. Vildin. I want to ask a question. How do we spot our mistakes from our jobs?
Okay, that's true. That's a really good question. Why I cannot see? I'm looking for the chat.
The chat box.
Yeah.
I think it's at the top. Is there any options?
Yeah. From Dharma, excuse me, I would like to ask, how do we spot our mistakes from our job? From discussion. That's the basic way to understand your mistake. When you have a discussion with your friend, you have to explain to them what you understand, right? And if your friend cannot understand, there are only two possibilities. Either he is stupid or you don't understand what you are saying. The second one, you need to discuss with your supervisor. Your supervisor has a lot of experience. They know the rookie mistakes, so they can tell you. If you are doing exercise, like mathematics exercise, easy to spot mistake. Very easy. So it is not interesting to discuss about that method. But argumentation, how do you spot your argumentation is not correct? What is the answer, Dharma? Through discussion. You got it? Perhaps Dr. Mark or Dr. Vera can give some more elaboration, perhaps?
I think it's very true, especially when during their defense for a final year project. It's most of the time for us as evaluators, we will look at students, the understanding of the fundamentals, not just doing, but understanding why you do it. And that is, I think, the most important aspect during the defense, because we do not, you have been doing a lot of advanced techniques. You've been using. What we're looking at is the fundamentals. How do you, when you use the instrument, do you know what are the principles of the instrument? I do not look at the outcome, but I look at how do you understand why are you doing it, and what are the limitations of the instrument. What are the why do not most of the time students will tell us that because my supervisor tells me to do it, to use this. and you don't know why. They just use it. So I think that's a rookie mistake. You must always know why and defend yourself, explain yourself, defend the reason behind your choice. That's how I think we will do less mistakes.
Very good, Dr. Mark. Yes. Dharma, listen. You must be able to answer why you are doing this. How, if you're going to answer how, it is easy to spot mistake. How, it's about mathematic method, right? But why you choose DFT? Why not go for Hartree-Fock, for example? When someone use, in our case, atom, and they do optimization, atom, but they put OPT, it is a mistake. There is no need OPT for atom. That's an example, practical example. So I hope you understand, Dharma. I lose my chat. Okay. All right. Dr. Vera, perhaps you want to get some more elaboration?
I think when we have a discussion, we ask a lot, and from the question, we know that in some point we don't understand about what we are doing. So yeah, they can find the rookie mistake when they have discussion, when they're asking and try to answer what's the problem in the team.
All right. Thank you. Yes. Thank you very much. All right, students. Perhaps you still have some question before we go for NBO demonstration. Dr. Mark students doesn't want to ask because they have asked Dr. Mark several times already.
I think today it's not a full attendance. Many of them are not here.
Yeah, admin, don't forget we need to take a picture before we end the lecture. Yeah. Please, guys, from my students, perhaps, maybe you want to ask, how do I make this presentation? I can give you the software. So what do you think, Dr. Mark? Should we go to the next step?
Just let me ask my students. Any questions? Don't know what to ask. They don't know what to ask.
Do not know what to ask or do not want to ask?
Anything about the module? Anything about the module, about your assignment? I think like some of them asked, one of them asked me, I don't know, is it Danish, is it? Yeah, will ask me whether do we need to, for our module, our previous module, do we need to set for our scan calculation, whether do we need to set our steps until 5 Armstrong? I say, I mean, for me, I think it's okay if you have a shorter distance, but most important, you're able to explain, show the curve. Why do you choose lesser than 5 Armstrong, even though the module tells us to do so. If you're able to find the minimum point, where the minimum potential, the potential well, and then you're able to explain. Also, we have got the lowest or the ground state structure. Then why not?
True.
Yeah.
True.
So it's very flexible. Our module is very flexible, actually.
Even you cannot achieve the solution, it is also fine. So you will say that, look, we try and we got a lot of error. You know that in module one, we by intention make some impossible calculation. So if you get error, that means you are correct in module one. Remember when you guys finding the many atoms, calculate for many atoms, you calculate the electronic configuration, and some of them does not match with Hund's rule. Why? Because it is Kunsam orbital, and Kunsam orbital is a fake orbital. So if your guys, you find that all of them follows the Hund's rule, perhaps you did some cheating. But that's fine, that's fine. So what do you think, Mark? Should we go to the next stage so they can, take a break after this?
I think there's also just one more. I think you also made you purposely made a mistake in the formula for the I think it's in module 3.
The ion what we discussed last time. Yes, it is not by it is by intention actually. So you guys, we expect you to calculate the second ionization potential using two methods. The first method that I demonstrated in the class, and the second one you do it one by one. So the second ionization potential is based on the first one, and you can check the value you got with from the what do you call that, the handbook of physics and chemistry, and you will find that the correct method to calculate is one by one, not what I demonstrated in the class. Mathematically it is correct, but experimentally you cannot take two electrons at the same time. It is impossible. So the way you ionized atoms is take out electron one by one, not two simultaneously. Because the model asks you to compare with the handbook of physics, right? Physics and chemistry. So that's the answer, Dr. Mark. You smile because you also make the mistake, right?
I think that's why you see that your results for the second ionization energy, it's very high.
Yeah,
it's huge. So it doesn't follow the book. But if I think only one group came to me and asked me about this. The other groups, I think no one asked about this. So when you actually if you subtract the second ionization energy with the first ionization energy, you get the one that you want, the second ionization energy, not subtracting the original or neutral one.
The neutral one.
So you can try and error. Which group is it actually came to me? Very good that you observe the difference.
You see,
there's only one group.
Yeah, that's the example of exploration.
So not necessarily whatever we say is correct. You have to explore.
Yeah, this model is quite new, perhaps for the students, Mark. So, but it is good for them to know, and perhaps next year the story goes on. They will tell the story to their kohai, the next year student. Yeah, we can get students get to be the macho again, like us during our time. All right, I think that's enough for discussion. Perhaps if they have some question, we can discuss later. But now we are going to move to the next session, because now you are motivated to explore. We would like to demonstrate to you guys how to read NBO calculation. Yeah, if it is not introduced in any module yet, NBO calculation, it will be introduced in the next module. But before we do the next module, I would like to explain to you what is NBO. So before, I would like to I will open something that you guys like, let's say your main reference, Wikipedia. You see, this is Wikipedia, and I go to natural bond orbital. Please listen carefully. You need this. Natural bond orbital. Wait, Mark, look at this. Now you see me, Mark? Expensive software, I will make a bigger. How to make bigger the font? View. Bagaimana cara memperbesar tulisannya ya? Ah, bro, can you see it now? It's bigger now, right? Not yet? Guys, can you see my screen now? With me, picture of me in the middle?
Yes.
In the class? Rofi, can you see? I can see you, Rofi. Okay, say like this, okay? Okay. Natural bond orbital. And it is purely belong, this concept belong to you guys, belong to Dr. Mark Clown, chemistry. In quantum chemistry, it is not from physics, all right? It is not from physics. So if I tell you this, do not get offended, okay? Not, Mark, I'm sorry if I explain this. This is your property actually. In quantum chemistry, a natural bond orbital is calculated bonding orbital with maximum electron density. What does it mean? Okay. You guys already knows about molecular orbital theory, right? Developed by Mulliken. So if you have hydrogen, 1s in the left, my left hand, and then the next hydrogen, my right hand, I will do like this, left and right. Left hydrogen in the ground state, 1s. And the next one, also in the ground state, 1s. 1s orbital, 1s orbital, when they create or construct molecule H2, these two orbitals will interact each other, 1s and 1s. And according to molecular orbital theory, this is physics, there will be a new orbital. The first orbital resulted from these two interaction are bonding orbital, and the next one is anti-bonding orbital. You know this, right? So in physics, when we talk about how to make molecular orbital, we jump from here, and then we get that using molecular orbital theory. Atomic orbital, according to quantums, the quantum mechanics, you remember 1s for hydrogen, right? If we take out 1s from physics to chemistry, what do you guys imagine about one electron in 1s? This one electron really occupied, stay in the room of 1s, right? That's chemistry. In physics, only part of hydrogen of the electron occupied 1s. Let's say 0.9 or 95%. And the rest is going to 2s, 3s, or whatever they want to go. That's physics. Dr. Mark, can you follow it?
Yes, yes.
Yeah, in chemistry, one electron of hydrogen stay locked in 1s room. So if you open that room, 1s orbital, you will see that electron is sleeping there. Really one electron. In physics, when you open the 1s orbital, you only see half of the electron. But electron is only one. Yes. Yes. Electron is real and it is, what do you call that? Discrete. You cannot have half people. How many students in the class? 3.5 people. You cannot say that. Either 3 people or 4 people. But quantum mechanics allows the electron behave like wave. And you cannot contain one fully wave in one room. So the wave may go out from 1s orbital. Let's say I explain this to my student. It is like in our religion, Mark, a man consists of jasad, and nafs, something that will go to the grave and finally go to the heaven, right? Our jasad stay in the earth. What do you call that?
Spiritual, your spirit.
Spiritual, yes. Yes. In Arabic, it is nafs. Nafs. In chemistry, you guys do not believe in that. Jasad and spirit is one. In physics, we believe jasad and spirit are two different things, but they can combine. Hey, look. So in physics, even though you store the jasad of electron in one s orbital, the spirit may go in anywhere. If the spirit stay in 2s, this 2s orbital, we call it Rydberg orbital. What is the point? The point is, in physics, electron is not discrete. It is wave. Density, we call it. Most of the density is 1s, but not all of them in 1s. Molecular orbital is the same. Molecular orbital is the same. And chemistry does not like it. Chemistry does not like physics a lot. For example, in physics, the wave function of 2p is not px, py, pz. There are some imaginary function inside that. You cannot even draw the picture of 2p orbital. And chemistry doesn't like it. It is impossible to have imaginary function. So what chemistry does is to project the 2p orbital to x, y, and z axis. So that's why we have px, py, and pz, right, Dr. Mark? Yeah, finally, Dr. Mark admitted.
Yes.
But it is chemist. If we don't have chemist, we cannot draw anything about orbital. And also in this case, we go back to our Wikipedia. Atomic orbital consists of electron that is a wave. Molecular orbital also consider electron behave like a wave. It is okay if you open one sigma orbital, you don't find fully 2 electrons there, perhaps only 1.9 electrons. Chemist doesn't like it. Chemist does not like it. So how chemistry understand this? How chemists understand this? You know that when we deal with atom, what you guys try to understand from the orbital, you guys try to understand from Lewis' perspective. Like electron valence, like a Lewis perspective. Be careful, Lewis, not Celana Lewis, okay? Celana Lewis is something else. So what chemist does is, first, atomic orbital, they purify it. So the spirit that already goes out from 1s, they take it back. Go back to 1s. Everything must go back to the orbital. So what we call it, this is natural atomic orbital. This is chemist. Atomic orbital is physics. This is chemist. This is when you deal with hydrogen. You open 1s orbital, you will see one fully electron in that room, according to natural atomic orbital. After natural atomic orbital, then chemistry allows some orbital to hybridize, like the famous one, 2s and 2px, 2py, and 2pz. 2s here, 2p here, 2s goes up, 2p goes down, and finally they are degenerate. Now we have a new orbital, we call it sp orbital, and it is hybrid. It was explained long time ago by Lewis. Then Pauling re-explained again using quantum mechanics. Now we have natural hybrid orbital. But this guy, this and that, it's still atom. It's still atom. Now From here, we go to natural bonding orbital. Now there is some interaction. There are some interactions. Atom interacts. Now there are bonding between them. There is bonding between these two atoms. In molecular orbital, in physics, we don't care about bonding. Who cares? There is no such thing of single bonding, double bonding, triple. There is no such thing in molecular orbital. If you look at HOMO, LUMO, HOMO -1, we only care about the distribution of electron. But not here. In natural bonding orbital, we care about the bonding between atoms in the molecule. And here, you see, this is hydrogen. According to Lewis, they share 2 electrons together. But in NBO, it is already developed using quantum mechanics. Not all of these 2 electrons in here, in the middle or share together, but some of them allows to go anywhere. So in NBO, it is already delocalized. Electron is already delocalized. And then from NBO, we go here. Natural, semi-localized molecular orbital. Now we have to look at in NLMO, this stage. We look at not only one bond, but many bonds. Electron got delocalized. Some still localized, but some of them delocalized. And finally, we got molecular orbital. When using the FT, we have from here directly, we got that way. And if we want to understand bonding between atoms inside molecule, we can still use molecular orbital, but abstract. It is better to use NBO. So usually what we do using the FT, using Gaussian, after we get molecular orbital, we ask a special software called NBO. NBO is also the name of the software, to take out the molecular orbital wave function and go back to NBO. So actually NBO is drawback actually. We got already the most advanced result and we take it out and then we understand with the simple way, NBO. You see that, right? NBO is actually drawback. Molecular orbital is the most advanced result, but difficult to understand, especially people like us. We want to understand the way Lewis understand. Right? Asistentika, Lewis, okay? Not Levis. Levis is celana. Levis 501. Now, I have asked Dr. Vera to run a molecule that we are going to learn today. I will open my Gauss view, and please don't ask where did I get the license. How to share my screen? Wait. Share screen. Okay. Mark, don't ask me where I get my license, okay? Where is Mark? Bro. Okay, we need to ask. We need to wait. So can we continue, Mark?
Yes, please. Yes.
Okay.
Carry on.
Guys, look at this molecule. This is the initial structure of C4H10. What do you call this? What is in English? Mark? Butane? Butana. If I said it when I was in high school, we call it butana. Butana, right?
Yes.
Yeah, because there is another, we confuse us. There is another one is Pak Tana. Yeah, Butana dan Pak Tana is husband and wife. stop the dry joke, Dr. Vera. We need to be concentrated here.
Oh my.
Like when I was getting lower back pain last time, Mark, I asked Rizka, you remember her, right, Rizka?
Yeah.
Rizka, please go to pharmacy and buy me Bapak Profen. But the correct one is Ibu Profen. And she complained, why? Because I am a man, I cannot take a medicine for Ibu. All right. This is Butana. Excuse my language. To be honest, I don't know how to pronounce in English. Butana. C4H8. C4H10. I'm sorry, H10. Again, this is the initial structure. And I will show the labels. You see, atom number 1 is carbon. Atom number 2, that's why I confused, because there is no me in the screen. C1, sorry, atom 1, atom 1 is carbon, atom 2 is also carbon, atom 3 carbon, and finally atom 4 carbon. And we are going to optimize it. And then after that, the same initial structure, I will delete one hydrogen from carbon number 2, atom number 2, and one hydrogen for attached to carbon number 3. So we will get butena. Sorry for my pronunciation. Butena, alkene, butina. How do you say that, Mark? Please teach me.
I think it's Butina. Butina.
Butina. Butina, okay, guys, not Pak Tina. Yeah, for Butana, we expect the bond between 2 and 3 is single bond, or in the another term for that is the bond order is 1. Okay, for Butina, the bonding between 2 and 3 will be, we expect at least double bond, or the bond order is 2. And finally, we will delete both hydrogen in atom 2 and both hydrogen in atom 3. So we will get, what is that, Mark? Butana, butena, butina.
Butine.
Butine.
What is in Bahasa? Alcuna.
Alcuna? No, must be bu, right? It is female. All right, anyway. So I already asked Dr. Vera. Actually, I rerun again because I don't trust Dr. Vera calculation. And now I'm going to open shell. And the calculation is already there. Can you see that, Mark?
Yes, we can see.
I have C4H10, C4H6, butana. This is butena, and this is butina. Yeah, sorry. I know, you know what I'm saying. Okay. Now, usually you guys will use Gauss view, right? But now Dr. Mark and I will bring you back to memory. We didn't have Gauss view during our time. We always use the output, the raw output file. We are going to study first butana. What we have to do? I don't have the visualization software. Let's say I have it right now, hijack version. How should I say that? Guys, pretend that you don't hear it, okay? All right. The first thing that we need to make sure is our calculation, our optimization is correct. Okay, I will show you the input file first. The input file is this one. GJF. Okay. I will use fin C4H10 GJF. Look, this is my input file. The yellow number is just the line number. Forget about that. Anyway, we need that actually, but not now. Look, B3LYP, I use, Dr. Vera used the lowest basis set. There is a reason why we need to do that. I will explain later. And then I run OPT, the routine OPT, optimization, and then frequency. And then I say population. Please take out the population result from CHK file and write it in log file. Not only that, also run for me NBO calculation to get the full population based on NBO, not based on molecular orbital. So there are two types of population. Population given by molecular orbital, we only have density. We don't know about the bond. And there is another one is NBO, population based on NBO. We can find how many electrons between two atoms. Pure chemists can understand that. Physics, physics. Forget about physics. And you have the blah, 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 blah. You know that, right? That I'm using Z matrix. Why? Because it is cool. It is macho. Coordinate Cartesian. It is for CC, you know. CC. All right. If you're macho, use that matrix. Now, how to make sure my optimization works well? Oh, there is a poetry. Dr. Mark said to me that there is one student answer by poetry. It is also correct, but it is not scientific answer. The answer is the stationary is found. First, let us grab the result. E grab minus n. Please write down the n is the line number. And then we will find this is the done. Okay. And we are looking for this special character. SCF done. It's C4H10 log. Why there is no ego? Typo. We have 1, 2, 3, 4, and 5. 5 iteration of optimization. You guys from UNER, Rofi dan kawan-kawan, remember we have two types of iteration, SCF iteration and optimization iterations. Please let this knowledge, share this knowledge to your friends from Malaysia. Especially Rafi, because I heard that you have toko di Johor, name's Rafi. Where is Rafi? Anyway, so the first SCF 9 cycle, 8 cycle, 8 cycle, 5 cycle, and finally 1 cycle. But still we don't know why it is stopped here. Is it because it is finished or it is error? So that's why we have to add another specification like stationary, right? Oh, look, after this one, the stationary point found. So it is already optimized after 1, 2, 3, 4 optimization cycle. Okay, why? Even though we already have the optimization, stationary is found, why the Gaussian still continue? Why? Well, it is because we ask the Gaussian, after you find the optimized structure, run for me the vibrational frequency calculation. And now we have to check the frequency calculation. We don't want negative frequency. Well, in negative, there is no negative frequency. We call it imaginary frequency. So we add another keyword, frequencies. Enter. Look. After I will clear. Okay. One. See, one. Wait. I will go left, move a bit. This is our comment just now. And this is the result. 1, 2, 3, 4. The stationary point found. And then it begins with the frequency calculation. And this is the result. Frequency mode 1, module, blah, 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 blah. We don't need to know everything. But we just look at, do we have negative frequency or not? No, we don't have it. So it is all okay. Without looking at the visualization, we just trust Gaussian. Oh, Gaussian. Why we trust Gaussian? Because it is the most expensive software right now. So even without looking at the visualization, of course, it is for small molecule. If big molecule, we still need to open the visualization. Now we go to input output file. FIM. I'm using FIM. C4H10 log. This is the output file. And we will find the NBO calculation. NBO calculation. Next, look. NBO calculation. Gaussian NBO version 3.1. If you are rich, you can buy an NBO software, and the current version is 6. NBO version 6, but it is different software. Gaussian only has NBO version 3.1 installed inside. If you want to go higher, then you have to pay another software. So I will not explain line by line. I will just tell you that the result of NBO is a lot, but what we need only the summary. So that's why if you go look at in this line, this is the way I use Control F in Linux. If you use text editor because you are CC, you will use Control F. But for macho men like Dr. Mark and I, we use FIM. This is what we use. / and then I type summary. I know by hand because it is I born with this skill, you know. Summary. Neutral bond orbital. Summary. But be careful. It is perhaps not from the final calculation because we have a lot of iteration, right? So we have to find what is the last natural bond orbital calculation. Next. You see, we need this now. This is now 3,000. Before was 1,000. In the line 1,000. It is not the final one yet. 3,000. Next 4,000. Next go back to 1,000. So the last one is in the line 4,000. 1, 2. This one. This is the last one. Dr. Vera, I need your help. Now look at this summary. We have molecular unit. I will go up. You see, natural bond orbital between carbon, which is atom 1, with carbon, which is atom 2. All right. And what we are looking for is carbon atom 2 and carbon atom 3. The next one is the occupancy. How many electrons are occupied between these two atoms? There are 1.99261 electrons, not 2. Why? Because NBO Mark, look at this. NBO already contain quantum mechanics. So NBO allows the spirit goes away from the jasad. Okay. And this is the energy. What is this energy? So this is the energy you need to take out to break out the the bond. The unit is heart rate. What is this? We don't have time for that. Oh, but we are curious. Be patient. Curious is number 1. Patient is number 0. Remember the story of Nabi Musa alaihi salam study under Khidir. Nabi Musa fell because not patient. He is curious, but he is not patient. This is what we are looking for. And BD mean bonding. You see, bonding between carbon 1 and carbon 2. And there is CR, core. Core does not have bonding because core mean inside it. And we have BD star. BD star, this is anti-bonding. All right. Now we are looking for C1 and C2. Sorry, C2 and C3. How many electron occupied? Dr. Vera, please type it down. 1.98850. Okay. Now it is not 2. It is not 2. Now we look for the bonding star. The anti-bonding. 2 and 3. Look, we have 2 and 3. It is 0.0. Dr. Vera, please type it down. 1415. 0.01415. So there are few of electrons, the cloud of electrons, let's say, or the spirit of electrons, occupy the anti-bonding. Oh, we have chat here. Yeah, bonding current. Thank you, Dr. Mark. So it is not pure quantum, it is not pure Lewis anymore, listen, guys. Because Lewis does not recognize the split between jasad and spirit. Quantum recognize it. So quantum is more religious, you know. All right. Now, how do we calculate the bond order? The number of electrons occupied the bonding minus the number of electrons occupied the non-bonding, anti-bonding, divided by 2. Please, Dr. Vera, 2. Dr. Vera, can you?
Yes.
Yeah, can you calculate for us?
Yes. The number is 0.98.
That's the final. After
Yes.
you divide by 2.
Yes.
So that's the bond order, guys. 0.9. But see, since we are friends, you know, Dr. Mark and Dr. Vera and I are friends together, so we can make it 1. So the bond order is 1. It means bond order 1 correlate with single bonding, according to Lewis. But the NBO does not give you guys the exact number. Why? Because there is quantum here. If you want to know what kind of orbital interact between to make this bond C1, C2, and C3, you want to know what orbital that makes this bonding. Then you can go up from NBO calculation, go up, go up, go up, go up. Look, there is here information about what kind of hybrid orbital create the bonding. Occupancy, we bond orbital coefficient, blah, blah, blah. We will find C2 and C3. This is between C1 and C2. Where is C? This one. C1, C2 and C3. C2 provide or donor sp3 orbital. sp3 orbital. This is the composition. And this is the how many percentage of the contribution of the C2. Forget about that. While C3 also provide sp3 orbital. So sp3 versus sp3. You only have one type of bonding between sp3 and sp3, which is single bonding. All right, now we will go to, yes, thank you, Dr. Mark. We will go, no, Tika. Thank you, Tika. Thank you, Celana Levis. We will go to the next one, CH4. I will just repeat my comment. I will clear so you guys can have a nice monitor clean. Oh, no, sorry, clear. Okay. E grep minus N. SCF done. For molecule H, C4H8 log. Oh, a lot. Why it is a lot? Because the starting point is the same. If I took the output from the first calculation and take out one hydrogen for C1, C2 and C3, and then run the calculation, the iteration will be less than this one. You got it right? And then like usual, I need to check whether it is already final complete calculation or not. I type stationary here, stationary, and then check the frequencies. Enter. Look, stationary found, and then this is the frequency, no negative frequency. The correct way to say that not negative frequency, but imaginary frequency. But since we are friends, okay, we will let it slip. Negative frequency. No negative frequency means, okay. Now we open the file C4H8 log and then find the summary of NBO calculation. Summary. It is okay, guys, if you don't have, you cannot do what I have done so far because you have Windows, I have Linux. It is okay. I want to continue. Linux is for macho, but I don't want to say that because I remember that Mark also doesn't have Linux. Enter. Look. Line number 1000. It is not the final one. Next, 4000. Next, 5000. Next, go back to 1000. So the final one is in line 5000. This one. Dr. Vera, please help me to write down the number. Now we are looking for C2, yeah, C1, C2, not this one, C1, not this one, not this one, not this one that we are looking for. C2 and C3. Please write down the occupancy, Dr. Vera. 1.99247. Okay. And then go down. Look, right below the first one. 1.978. You got it?
Yes.
But before we continue, look, Dr. Vera, look. The NBO, the summary already give us the clue 1 and 2. Look. So this is the second one from the first. You see that? So NBO give us a clue. It will be two type bond order 2. The bond order is 2. Now we are curious to look at the energy. For the first one, this one, look the energy of the bonding, 0.6. But the second one, Dr. It is weak. Look, you can see that?
Yes.
In the first one, 0.6 minus 0.6. It is stable. But the next one is easy to break. So that's why, Dr. Vera, the first bond the occupancy is almost 2. While the second one, you see,
Yes.
why? Because weak iman. This is weak iman. Easy to disturb you. All right, we go down. This is bonding. Perhaps there is still anti-bonding. This is anti-bonding, 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 anti-bonding. This is what we are looking for because we know already the clue 1, 2. Just look at 1, 2. This one. The first one is 0.00941. You got it right?
Yes.
And the next one, which is weak iman, 0.04, or a lot of electrons in this anti-bonding, Dr. Vera. And if you look at the energy, Dr. Vera, the anti-bonding has a positive energy, Dr. Vera, while the bonding has negative energy. But do not get it wrong. In society, negative energy means bad. Yeah, Dr. Lucia generate negative energy mean Dr. Lucia is bad. But in quantum, negative energy means stability. The more negative you are, the more stable you are. So do not flip this. Okay, Dr. Lucia, do not be proud of because I generate or negative aura means I am stable. No, you are labil if you are generate negative energy. While negative energy in quantum, in chemistry as well, no need quantum, negative energy mean attractive. Attractive. You attack, you attract, you pull out. Like gravity. Gravity has a negative energy because attract object. While positive energy, Dr. Vera, mean repulsive. So do not get it wrong, Dr. Lucia. Remember that people always say to you, oh, Dr. Lucia, you always provide negative energy. It means bad in society. Okay? So what does it mean if some electrons occupied bonding with a positive energy? Means they want to break the bonding. So it's like between me and Dr. Mark, few of our students try to separate us because they don't like us. So we call them has a positive energy. They stay in the anti-bonding. So they want to separate between us. All right. How many bond orbital, Dr. Vera, for this case?
1.95.
Not 1.95, close to 2. So we call it, they have double bond. We will look at the visualization later on, but first now we want to see the output file. Finally, we are going to the final molecule, which is C4H6, Pak Tinu. Yeah, the final one, Pak Tinu. We have Butana, Butena, and finally Pak Tinu. Look what we are going to have. I will clear it. Clear. All right. Let's see. Guys, look at this. Look at this. Look at this. This is will shock you guys. Ta-da! We still have many iteration. Remember, this is SCF iteration. Rofi dan kawan-kawan, please share this knowledge to your friend. And this one, blah 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 blah, is optimization iteration. And finally, we have stationary point. But look, we have negative records. Oh, anyway, I forgot to explain to you guys what kind of orbital created the bonding order 2. Let's go back to this one. And summary. Not this one, not this one, this one. We did calculate this before, right? We got bond order 1.95. Correct, Dr. Fena? And
Yes,
then
correct.
we are wondering what kind of orbitals or hybrid orbital created this bond. We go up C2 and C3. C2 and C3. This one, right? C2 and C3. SPU 1.2, 1.6, or this is SP2. This is SP2 in Lewis perspective. In quantum perspective, SP 1.6 from C number 2, and from atom number 3, carbon number 3, also SP2. This is the first bonding, very strong, very strong, SP2. The next one is this one, bonding number 2, S 0%. So this is P and P. What kind of P? P, this P constructed by, this is 1s, 2s, 2px, 2pa, 2pz. So this is pz versus pz. So we will expect sigma bonding, but it is weak Iman. Weak Iman. This
Pi
is strong.
bonding, you mean?
Yes.
You mean pi bonding?
No, pi bonding
Pi.
is this one, Dr. Mark. This one. This is pz versus pz.
It should be pi, right?
Z axis is always between, in what do you call that? Yeah.
Head on.
Yeah, it's always like that. Okay. But perhaps Dr. Mark is correct. We don't know. We need to visualize it. We need to visualize it. I think it will be pi because sigma is usually strong Iman, right, Dr. Mark?
Normally sigma is head on, but I think conventionally in our chemistry book, the z-axis is most of the time it's the pi bonding, the
Pi
sideway.
bonding. Yeah, perhaps you are
But
correct because it is NBO. It is yours knowledge.
But it depends if we use the z-axis as the sigma bonding.
Yeah. Gitu ya.
X
And this is the
or
reason,
Y as
Dr. Mark. Yes, thank you, Dr. Mark. This is the reason why I use STO3G basis set. If we use higher basis set, it will a lot of contribution here. We don't know anymore which one is PX, PY, PZ. We don't know. I use STO3G to introduce to you. Look, this is how do we read this? 2P, 2S, oh, sorry, 1S, 1P, 1S, 2S, 2PX, PY, PZ. And if you get extra basis set, it will go continue to 3S, 3P, and so on and so on. And this is not exact. This is quantum. Okay, this is quantum. Okay, just pretend you know already. So I think, but I still think, Dr. Mark, sigma is stronger. Sigma is stronger than P.
Yes, sigma bonding is stronger than pi bonding.
Yeah, so that's why I suspect you are correct. This is my suspicion, to be honest. This SP2 will make sigma bonding. If you look at this, the hybridization comes from 2S, and 2PX and 2PY. Yeah, I cannot imagine that it is because if we look at the energy, the bonding number 1 is more stronger than the bonding number 2. So we will expect this is the sigma, this is the P bonding. But anyway, it is not our concern right now because our concern is the bond order of the bonding. And the answer is 1.95. All right. I will go now to the final molecule, Pak Tinu, yeah. Bapak Tinu, and we have negative frequency. But do not worry. We expect there will be negative frequency. Why? Why? First, the frequency calculation, guys, really heavily depend on the basis set you choose. So if you increase the basis set, there are a probability that the negative will disappear. Even though you use highest basis set and there is still negative frequency, we still can see that, look how much, -10, -10. We can ignore it. Usually from our practical experience, if you negative frequency higher than 100, then it is a serious problem. It is not, you cannot ignore it. But it's below 100, friend to friend, teman sama teman, we can ignore it. There is no physics behind that. It is pure computational. Sometimes computational can produce artificial result. You have to remember that. So that's why in our module, we always try to remind you guys there are always two problems in our calculation: physical problem and computational problem. And sometimes computational problem can interfere with the physical problem, like this one. Thank you, Dr. Vera. Now we will open the file Pak Tinu, and we will calculate the bond order. Like before, for macho man, summary, this is the first one we find, but we suspect it is not the final one. Let's go to the next one, 4,000, not next one, 5,000, next one, 1,000 again. So the final calculation is in the line of 5,000. This one.
I'm sorry, Dr. Fabian. I think
yes,
we should open the file C48.
Oh yeah, thank you. This is still Butena. We are looking for Pak Tinu. Yes, thank you. Summary. So it is okay to make a mistake. Remember, I'm not shy in it, Next, 4,000, 5,000. Okay, 5,000. Okay, this is the final one. Dr. Vera, like usual, please take a note. Since we has some experience already, we don't need to check one by one. We let's just check. This one, 1, 2, 3. 1.99. Dr. Vera, 499.
Okay.
Okay. And then the second one, 2, 2, 3, 1.97771. Okay. I said it again, 1.97771.
Okay.
You can see the difference already, right?
Yes.
Weak iman, remember, this is strong iman. This is Dr. Mark. Weak iman. And finally, number 3 is 1.97766, close to each other. And the number of electrons occupy this bonding related to the energy of the bonding. Look, if it is strong iman, look. If it is weak iman, look. Now we go down, looking for the anti-bonding. We got this. Dr. Vera, please type it down. 0.00744. And then the next one is 0.04707. And finally, 0.04708. Please calculate that.
2.92.
2.9, guys. Where is Dr. Mark? His spirits go to Rydberg orbital.
Sorry, I'm writing something on the whiteboard.
Okay. You see, guys, Rydberg orbital, valence orbital, Rydberg orbital. This is what I was talking about. I will not explain more than this. Why Rydberg is 0? There is some explanation how to understand, but not this time. So what we got, Dr. Farah, with the bond order? 2.9.
0.9.
Because we are friend, it becomes Dr. Farah.
Triple bonding.
Yeah, triple bonding. Well, you got bond order, you got what? 2.9. But according to Lewis, the bond order always discrete, either 3 or 4. There is no 2.9. So that's why I say to you, if you got 2.9, why? Because it is NBO, and NBO already based on quantum mechanics. But to understand 2.9, we have to say, since we are friend, 2.9 becomes how many?
3.
Dr. Vera?
3.
3. Okay. Bond order 3 refers to triple bonding. And if we want to know how the bond is created, we go up, 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 up. Where is it? This one. We try to find C2, C3, and we got it now. 5, 6, 7. The first one is SP. SP, or case P.08. But remember, we are friends. So we translate it to, we genapkan, we round it. Yes, we round it to 1. So it is SP, SP1. And C3 contribute also SP1. The bonding number 2 is 0 from S. This is P, P and P. And P and P, this is PX. See? Sorry, PY. And finally is also P and P. This is PZ. I think if we look at this, perhaps Dr. Mark is correct. So between atoms, not Z like in physics, but X perhaps. But we don't know. We have to look at the visualization. But anyway, this is not our concern right now. We know that from our chemical textbooks, usually chapter 1 or chapter 2, SP, SP bonding 3. SP2, SP2 bonding 2. You know, double bonding. SP3, SP3 single bond. Right, Dr. Mark? That's the formula, right?
You can see like that.
Finally, guys, I will go back to our Gauss view, and this is the initial, right? The initial, look, initial. I name it, I don't lie. Usually, if you want to trap your friends, change the name like final, but it is not actually final. We have here the final result for butana, butana. And this is butena, double bond. And finally, patinu, the last one. But do not deceive. Be careful, guys. This is visualization, can deceive your eyes. It's like a magic, you know. Even though the visualization show you 3 bonds, but you can set the value and make it 1 bond. So do not trust it. Do not trust it. And the way we demonstrate to you guys, when we do not have visualization software, but you have visualization software like me now. So what are you going to do? Do not open, you don't have to install Linux. You don't have to be macho right now. Well, we still have to you guys to be macho. So the best way to do is macho way, but if you don't have time, excuse yourself to be CC sometimes. You go to result, you see, result, go to bond property. Can you see that, Dr. Farah?
Yes, doctor.
Bond property.
Yes.
Click bond property. Click bond property. You see here length, and click show number. Now you have length. You don't have to click anymore. Caca, Tika, Rana, you You still use Camcraft version, right? Hijack version, right? You have to click. So yesterday. Now Gauss View is the best right now, guys. The best software, the most expensive software. If it is already in your hand and you don't use it, you waste your time. Do not be like us. Dr. Mark and I, we use Linux, because we think we are macho. Now even as CC girls, CC boys can do computational chemistry. All right, this is length. This is length. What is the length between this and that? 1.4 and so on. And finally, guys, beside length, Gauss view also give you the next one, order. You see, order. Click order. Ta-da! Now you have bond order. 3, 1, 1, and this is 1, yeah? 3. Oh, so no need to go to Linux, type Vim. Do not be macho anymore. Don't need to be macho. Let only Mark and I be a macho. You guys can be CC. Now look, if we go to the Butena, we do the same thing. Result, you see, result, and then bond properties, go to bond order, yeah, bond order, and click show numbers. Ta-da! You will have bond order 2. Lucia, Dr. Lucia, you see how easy to be CC?
Yes, Dr.
Yeah,
Febrian.
be CC, okay? Let me and Dr. Mark be macho. And finally, Butana. We expect this will be 1, okay? 1. Result, bond property, and finally order. Click show number. Ta-da! You have 1. You don't have to go open Linux, buy MacBook to have nice Unix system. No. And next week, we will use this to analyze, to understand resonance phenomenon. The first phenomenon in chemistry explained using quantum mechanics. There is Dr. Fazira. I didn't know. Oh my God, Mark. Is Dr. Fazira macho?
Yes, Dr. Fazira uses. Yes, Dr. Fazira uses MacBook, so.
But that's not important thing now. The most important thing is she macho or CC? If we don't do NBC calculation, can we still visualize the bond order? No. The answer is no. But if you are macho, you can use molecular orbital, extract the molecular orbital, calculate using the operator, moment dipole operator, then you will get the bond order as well. But that's for macho, Dr. Fazira. Don't do that. Yes, NBO. During my doctoral, I used molecular orbital wave function to calculate the bond order, and it made me cry a lot. So don't do this. There is a simple way actually, but yeah, that's the answer, Dr. Fazira. I'm sorry I didn't notice you, so I'm sorry for my language, Dr. Mark. It is Dr. Mark asked me to do this, Dr. Fazira. I usually so polite, All right, I will say it again. Next week, we are going to use this knowledge. Do not use, you can use Gauss view, okay? You can use Gauss view. We will use Gauss view next week. And why, if you ask me why I demonstrated something that you guys will not use, so that makes you appreciate the hijack pirate person you use. Use it to get some knowledge. Do not just stay in your laptop and never use it. And resonance is the first phenomenon explained using quantum. So there is no way we have to study it, because that's the first time chemist people appreciate quantum mechanics. So that's all for me. Before we close the session, I will go back. I will first close stop share first, and then invite Dr. Mark and Dr. Vera and Dr. Fazira. Dr. Fazira first, because we haven't heard her opinion since the class begins. Please, Dr. Fazira, step forward.
Hi, Assalamualaikum.
Waalaikumsalam warahmatullah.
I was here from the beginning. I
didn't see so.
enjoy everything. And I think it's very good thing for the students, like because some of the students of UTM come and ask me like this module might be too much for them, and they will like say when are we going to use this? And I think for you guys this is actually the best thing that you can actually directly visualize for what you have learned so far. Relate to what you have learned of the, this is the basic thing, right? Single bond thing, apa yang you dah belajar daripada tahun 1. So this is one thing that you can actually see directly the apa tu, the connection. So things that you can explain to others as well. Senang you nak faham kenapa single bond macam ni, kenapa double bond macam ni, because of the occupancy itu sendiri. And you can see when you change the occupancy of the electron dalam satu tu, it will change the energy as well. So this is a very strong argument for you. Okay. I think that's it.
Thank you, Dr. Fazira. Mark, why you didn't say that Dr. Fazira is here?
I'll give you a surprise. You always surprise me, so now it's my turn to surprise.
Yes, you're correct. I'm surprised.
Okay, so for me, I think like just what Dr. Fazira mentioned. So now you have the tools with you. Use it for your thesis. Use it for your, if you're going to write papers, scientific papers. Use them. But don't forget put my name in as well. No. So, but please explore them. And if you have any problem, I believe some of your supervisors have also asked you to use Gaussian for your projects. So you can also come to me, refer to me if you want. Okay. If you have a very good project, we can maybe translate it into a paper, scientific paper. That'll be good as well. Okay. Besides that, I think for your assignment for module 4, you don't forget that you need to submit on the 26th on Sunday, this coming Sunday.
Next week, right?
After that you have your, yes, this coming next week, the next Sunday, not today, the coming one. And after that will be your semester break, right? After your semester break, we will have tests. Okay, so I'll discuss this with Dr. Fazira on how are we going to conduct this. Okay, so we'll inform you in soon, right? So I think that's all for me. So for the next class, I think it's already a semester. It's already the mid-semester break. So our next class will be after the mid-semester break. Is it okay, or is it too long a break?
No problem.
You have 2 weeks. Only then we go into resonance.
Our plan for our student, Dr. Mark, we will continue to do the exercise. So we hope that inshallah my students can help your students during the next assignment. That's our intention, including Dr. Vera's student as well.
Yeah, Dr.
Okay.
Mark, week 9 is
Yes.
resonance. Week 9 nanti kita akan masuk resonance, right? After
Next week, pekan depan, minggu depan Dr. Fazira, resonance.
Week 9. Yes, week 9.
Minggu depan sudah mid semester break. Week 8, then week 9 is resonance, right?
Yes, now is week 7. So week 8 is our mid-semester break, and week 9 we will come back.
Oh yeah.
We will have resonance.
Next week you don't have class, Dr. Mark?
Break, mid
Oh,
semester.
okay.
Mid-semester break. So it starts on 26 on Sunday. So that's the week for our semester break, mid-semester break.
Ya. Ya, Galang dan Mbak Sri, dengarkan itu ya. Pekan depan, alhamdulillah kita nggak ada kelas, tapi kalian tetap kerja ya supaya kita bisa bantu student Dr. Mark nantinya. Kita tetap melakukan latihan untuk resonans. Insya Allah tetap akan saya jelaskan nanti. Ya, mana Mbak Sri dan Galang. Tolong angkat tangan. Jangan angkat kaki. Alhamdulillah. Terima kasih. Dr. Vera, silakan.
Thank you, Dr. Febian. I think my student will struggle a lot to learn a new thing about chemistry because we are engineering physics. But I heard that I think this week, like my president of university come to UTM and they plan to have MOU. I
Between
think-
ITERA and UTM.
Yes, I think they have planned to meet.
Wow.
I don't know, maybe next year. So maybe if there is exchange student, that will be good for them to learn this. Yeah, I hope
Okay.
maybe next year UTM will be the host of the joint class, right?
Yeah.
So
We
maybe
plan that. Yes.
yeah. So
Yes,
maybe
very good.
we will plan to maybe send our student to UTM.
Yes, please come.
Send to Dr. Fazira. Dr.
Yeah.
Fazira is nicer than Dr. Mark.
Yeah.
The president will help me, please.
All right. Thank you very much. Perhaps Dr. Mark, perhaps your student want to ask something. We still have some times. 10
Okay,
minutes.
we have about 15 minutes. Any questions?
So we still have resonance and then kinetics of methyl atau isocyanide and then kinetics of cyclopropane, right? 3 case study. So all of those 3 needs to be submitted, right?
Yeah.
Semua sudah diam.
No questions.
Dari Unair, Galang dan kawan-kawan, ada pertanyaan? Baik.
Right, don't forget, I think we also need to, do they need to upload any evidence of the discussion today? I think
We
there's
don't
no.
have, today is
Don't have.
special edition, Dr. Mark.
Okay.
You forget, you
But we
always
just
forget.
do we need to take a picture or something
Yeah,
together?
picture, yes. Picture together, yes. So please, guys, later turn on your camera. Thank you. Admin,
Okay. Everybody, please open the camera. Ready? From slide 1. 1, 2, 3. Okay. Move on to the slide 2. Please open your camera. 1, 2, 3. And the last slide. Last slide, please open your camera. 1, 2, 3. All right. I've done take the picture.
thank you, Admin. Sukma. All right, Dr. Fazira, Dr. Vera, and Dr. Mark, I think that's enough for today. What do you think, guys?
Yes, there's a lot we have learned today actually.
Yeah, a lot of learned, and they don't have to do some exercise, so good for them, right?
Yes.
Habil, we will see in next January. I will visit you, Habil. I see you walking around.
See you.
Yeah, next January, inshallah, we will visit you. So you have to be there, okay? I will take
I will be here.
I will
Waiting for
take you to Roti Canai.
Kita
Yang
boleh pergi
mana
Toko Raffi.
Yeah, Toko Raffi. All right, guys, let us close this session. Very nice session. Thank you, Habil. With Alhamdulillah Rabbil Alamin. Subhanakallahumma wa bihamdika. Asyhadu an la ilaha illa anta. Astaghfiruka wa atubu ilaik. And do not forget, jangan lupa doa untuk saudara-saudara kita di Palestina dan Gaza. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Dr. Fazira,
Thank you.
Dr. Vera, and Dr. Mark.
Thank you, Dr. Vivian, Dr. Vera. Thank you, everyone.
Untuk asisten kita evaluasi dulu ya. Jadi jangan pergi dulu.